Okay, let's demonstrate some of the time-saving features of the CAD editor that can be used to maximize users' productivity when doing CAD work. So to begin with, before I actually demonstrate the features in the CAD editor, let's attempt to compile a set of CAD drawings and take a look at some of the errors that are produced by the CAD compiler. To compile a set of CAD drawings, select the module in the left-hand side of the client software. At the top of the client software, you'll see various speed tabs. Select the one that says CAD File Utilities and click the Compile CAD Drawings button. Or you can either right-click on the module and a speed menu appears. Select Compile Module. This invokes the CAD compiler. Now the module should already be selected in the file specification area of the CAD compiler. All you have to do is now click the compile button and the compiling process will commence. Any errors that are found during the compile process will appear as an aqua-colored line in the compiler status log. To move quickly to the error, you can either scroll to the error, or you can simply press the F8 key on your keyboard. It'll take you to the very first error. If there were more errors, you can move to the next error by clicking on the error, or you can type in the F8 key on your keyboard to move to the next error. To see what this error is, you can double click on it with the mouse and it'll invoke the CAD editor and take you right to the line that is in question in this particular case. Here we have an error that says block 2110 specification 2, the line is not connected to it properly. So let's double click it and go and examine what's going on here. The CAD editor has now been invoked and we're zoomed in on the block in question. And if I want to double check what that error was, I can quickly go to the edit menu of the CAD editor and show the verification error. And here it is again. This is the same error message that was found inside the compiler. So it's block 2110 specification number 2. So let's take a look at this line that we're in question of here. Here's the line. If I identify it, it looks to be like it's drawn okay. I can verify quickly that it has been connected properly to the input spec by identifying the block and attempting to move it. And now if the line changes color, then I know that it is connected successfully to either the input or the output of the block, as you can see here. So there's no need to actually move it. I know that the line is drawn correctly here. Therefore, the error that has been encountered by the compiler lies elsewhere within this line. So now we start to trace back through the line to see where it goes. And it goes to the output of a station block, this being the set point of the station block. So there's something going on with the line. If I identify the line, let's see if it hasn't been broken into 2 or more segments. No, if I identify the line, the whole line gets identified. So there must be something going on with the line at its origin, or the block output of the station block. So let's take a look and see what's going on. Let's identify the block and let's attempt to move it. And no, the line hasn't changed color on block number 2115. The other lines seem to change color, so that means that those other lines are connected properly. So there's a problem with this line being attached to this output, and hence the error message has occurred in the compiler. So let's take a look. Let's zoom in a little bit further here on this output and see what's going on. Now at the top of the CAD editor here, there's a series of buttons. And if I click on the one that has the purple cross in it, this displays all the input specification hot points and the block output hot points, i.e. these are the actual physical points of the blocks where lines need to be connected. And so far here, everything seems to look good, but we know that there is an error because the compiler has spotted an error. Let's turn on the fourth button here at the top. And this displays the line vertices. So let's see what's going on with the line vertices here. And when you click on this button, the line vertices will be highlighted with a red crosshair. And I can see automatically that here is the problem. The line vertex ends here, so we have an overlap that has occurred. This line vertex shouldn't be located here. It should be located on the actual block output. So let's move it quickly. identify the line, and there's a nice little feature in the Edit menu called Move Line Vertex. You go and you select the line vertex and click and release, and it should identify the line vertex for you. However, we have an error message that has occurred here. The point is not on a line vertex. This is because the grid display of the CAD editor has indicated that the CAD block and the line is not on the standard 20 by 20 grid, as we can see here. So we have to refine our grid a bit. Let's move down to the 10 by 10 grid, and this should hopefully pick this off. When you move the grid down below the standard 20 by 20 size that CAD EWS and WinTools use, you'll see that the grid here is a combination of the standard grid plus red crosshairs. Now the red crosshairs are the standard 20 by 20 grid, and the regular grid points are your now new 10 by 10 grid. Now we can identify the point by clicking on the Edit menu, Move Line Vertex, and click on it. And now I can move the mouse. You don't have to drag it here by holding the mouse button down. Just click and release to identify the point, and then just move it onto the output and click it into place. And there we have drawn the line correctly. Speaking of the grid here, this is a common problem that arises in a lot of WinTools and CAD EWS drawings, in that someone has drawn this drawing off of the standard 20 by 20 grid. So how can we fix that? Well, you can either go through and manually select each point and drag it till it coincides with the 20 by 20 grid in the red crosshairs in this example. There, now the block is on the actual output. Or what you can do in this case, let me undo that. We can select everything in the CAD drawing and just temporarily move it down on a diagonal, and it hopefully is now on the 20 by 20 grid. Well, it's almost there. I've got to shift it over by 10 more. Let's select everything. And I should be on now, the 20 by 20. I'm still not there. I got to move it over just a little bit further. And hopefully that's drawn it now. I'm still not getting it. And there we are. Now we're on the 20 by 20 grid here. Let's turn off the line vertices and the block outputs. Let's save our CAD file here now that we've corrected this problem with the line. Let's get out of the CAD editor, go back to our compiler, which will be down in the taskbar of the operating system. Let's clear the status and let's try to recompile this. Now that we have the line drawn correctly, we should hopefully get a clear compile. Now the CAD compiler will attempt to make a configuration file which is the same name as the module header file for the module of CAD drawings, only with a different extension, CFG. If a file name already exists of the designated target configuration file name, it will prompt you if you wish to rename this file. If you click no, it'll automatically overwrite it. If you click yes, you have the opportunity of specifying a new file name. And we'll just type one in here quickly and then save it, and your configuration file now has been saved successfully to the hard disk. Let's get out of the compiler, and here it is right here in the client software. So you can double click on it and take a look at the configuration file. We can take a look at any of the specifications by double clicking on the block. Let's go back into the CAD editor here. Let's take a look at how we draw things if we're designing new logic. Drawing lines is a little bit different than using WinTools. For example, if you want to draw a line, specify the type of line. If I want to draw an analog, I can specify analog or digital or dotted or dash dot type lines here. I'm going to specify analog and click on the line drawing button, and you'll notice that the cursor changes to that of a pencil. Now, users can specify the first point of the line by just moving the mouse to a designated point, clicking and releasing the mouse button, and then moving the mouse. You don't have to hold the mouse button down to perform this. Just move the mouse and click and release on the next point. When your cursor actually makes it over top of a hot point, i.e. an input of a block or an output of a block, or a point on a cross-reference bubble or a constant block, you'll notice that the cursor changes to that of a pencil with two lightning bolts. That means that you're on the appropriate point. You can click and put the point into place. When you're finished drawing the line, right-click, and the line is now drawn, and you can continue to draw further lines. Right-click to stop that line, and you can continue to draw even more lines if you wish. Or if you wish to go back to normal mode, simply right-click, and you're back to normal mode, and the cursor is changed to the standard Windows error. When drawing text, specify the text that you want to write in the dialog box after clicking the text button at the top here. Set your size and the orientation in degrees, 0, 90, 180, or 270 degrees. Then click OK. Now you don't have to drag here again, you just have to move the mouse. And you'll notice that there's a red box that appears, and this shows you the extents of the text, where it's going to go. Click it into place, and there's your text. After placing text, you're automatically put back into normal mode. If you want to draw a rectangle, click on the rectangle button. The cursor changes to an arrow with a rectangle beside it. Click and release a point and just move the mouse. You don't have to drag again. And click into place your second point. You can continue to draw rectangles as you feel fit, doing the same thing. When you're finished drawing rectangles, simply right-click and you're back into normal mode. And I'm going to undo a lot of this because we're starting to get a little messy here by clicking the undo button. And we're back to where we were when we opened this drawing. To draw a circle, same thing. Click on the circle button. Click and place your center point. Release. Now move the mouse. You don't have to drag again. And click on a radius point. Click that point into place and your circle is drawn. You're still in circle drawing mode, so you can, if you wish, draw more circles the same way. To terminate drawing circles, simply just right-click. Arcs are very similar in nature to circles in that you draw a center point, release it, move out to a radius point, click the radius point in, but then you can move the mouse to draw a secondary point. And your arc is now drawn. Once again, we're still in arc drawing mode, so we can continue to draw arcs as we feel fit until we decide to right-click and terminate and put ourselves back into normal mode. Junction points are used to join two lines together, but we've got a really nice feature built into the CAD software such that if I wish to automatically connect lines that I'm drawing, let's draw a couple of lines here. Let's draw a line from here, this point here, down to the first input here. You'll notice that the junction point has been automatically placed in this line here. If I want to add a second line, we'll do the same thing again. And after we're finished drawing the line, the junction point is automatically put into place. If I want to turn off that feature, just unclick this button, and if I draw a third line, you'll notice that a junction point hasn't been put into place. I can manually put one in if I choose to do so. A word about deleting lines too. In this case here, take for example, if I identify this junction point and attempt to drag the lines around by rubber banding here, you'll notice that we've got 3 individual lines that are connected to this junction point. If I delete one of the lines going into it, I'm now left with 2 lines. If I delete the junction point, it'll automatically merge the last 2 remaining lines into one continuous line. Let's move that back. When drawing constant blocks, click on the constant block button at the top, and a dialog box will be shown displaying the block number and a brief description as to what the constant block is. Specify the block number or the type of block, click OK, and you can draw your blocks out as you feel fit. You can continue to draw them as well too until you right click, just as if we were drawing lines and circles. The right click of the mouse button will terminate the current feature and put us back into normal mode. Drawing function blocks that are defined by users in the available user block space is a little bit different because we have different classes of function blocks to work with. So let's attempt to draw in here, say, a function code 30. And we can either type it in or we can scroll to it in the selection list here. But take, for example, if we don't know what block number we want to assign to it because a previous block number has been used elsewhere on another drawing, a very handy feature here is the block address map. Clicking this button invokes the block address map, and we can see all the addresses that are used by other blocks in other CAD drawings. So if I want to say choose a space that's available, I simply just double click on it. It'll automatically fill in the block address number. Click OK. Once again, we're just moving here. We're not dragging by holding the mouse button down. We're just moving the mouse and click the block into place. And you can put down multiple blocks if you wish by keeping drawing the same type of function code, but you'll notice that the block address has been incremented properly. After you're finished dropping the block in, you may want to identify it and change any of the values in the internal specifications as you feel fit. Because these are new blocks, if I want to assign a tag to it, all I have to do is click on Edit Tag, and it says it could not locate a new tag record in the database. Do you want to create a new tag? And we'll go yes. It'll tell you the available block or tag indices that are available here, and it'll automatically choose one for you if you wish to do so, or you can manually choose one. I'll let it choose one. It's found tag index number 9, and I can start assigning tag names to it as I feel fit. And then click OK, and the tag is now added to the ARCAD tag database. To verify this, click on the tag button at the top, and you'll see the index, the name of the tag, and the description of the tag underneath the block. If I want to display the tag or the function block specifications, there's a button up here called S1, and it'll show me all the specifications underneath each block. Now I've drawn these blocks a little close here, so let's move one of them over so you can get a good idea as to what is displayed. And here we have the internal specifications for a function code 30 displayed in the CAD Editor. And there now I've got the tag information there as well too. Okay, and we've just assigned a new tag to a block, but I'm going to delete all this work that we've done. But the tag will remain. If you delete the block, it'll remain inside the tag database. The last few buttons here for drawing are the user shape, user macros, system shapes, and system borders. They're all very similar in nature with the exception of the user macros. You have to specify a starting block number for the macro. But each one of these dialog boxes has a preview window that you can activate by clicking on the preview button. And you can take a look at what is contained inside the user library or system library by looking at the preview of it. I'm not going to put the macro down, but instead I'll put a system shape down. That's a good one. And there I've just drawn a small little I/O bus. Okay, so let's delete that. Now let's show, we've briefly touched on it in one of the previous demonstrations, but we'll refresh your memory here again about hyperlinking between CAD drawings. Two ways of doing this. If I want to see where an output is coming from, I can click on the block, or the cross-reference bubble in this case, take a look at the item properties. And we can see this is an IREF. We can see our bubble text and our descriptor text. But clicking on the View Connections button, it will query the cross-reference database and show me that there is an OREF that matches this one on another page elsewhere. I can double-click on the entry. It'll automatically load it up and take me to that point. And there it is there. If I'm drawing a new cross-reference bubble, though, the View Matches button will appear as opposed to View Connections. And if I want to, let's take, for example, put an OREF in here. And we'll call this K1-333FT622. And I'll leave the typing there without putting in the 20 space raw. If I click on View Matches, it'll do a query as to what I've typed in already. And I can even narrow this down. I've got 5 records already that match in the cross-reference database. By selecting one more key, it narrows it down to the matching one, and I can right-click on it and copy the entire text into the descriptor field of the cross-reference bubble so that we have a perfect match. But it's already, this is an OREF that we're drawing, and this is already being drawn on a previous CAD drawing. Hence, we can't have duplicate OREFs on a set of CAD drawings. So let's change this, say, to an IREF. We should be able to draw it now. And there we've got a duplicate of what we have right up above it. So nice little error checking facilities are built into the CAD editor to make your life a little bit easier. Getting back to the hyperlinking, though, there is one other way of hyperlinking between drawings, and that's by taking a look at the internal specifications of the configuration file if it is in the same subdirectory as the CAD drawings. Identify the block, and instead of selecting item properties, take a look at the CFG file properties. And in this case, we'll be able to see the input specifications. We've got a block 164 connected and a block 135. Simply double click on it. It'll take me right to the block. Let's take a look at the other ones. 135. That's on another CAD drawing. Now, it's not loaded up in the CAD editor, but it'll ask you if you want to load it in. And let's click on yes, and it'll take me to block 135. There we are. So we've shown you how to hyperlink through cross-reference bubbles, and now we've just shown you how to hyperlink between CAD drawings using the configuration file specifications. And if I have a function code that has a cross-reference bubble into it, I don't need to take a look at the configuration file properties. I can just look at the item properties of the CAD drawing, because those types of function blocks have internal specifications which have a block address in them. You can just double-click on them and it'll take you to it. So let's actually find one here, and I'll show you a quick way of finding them. Let's take a look at the function block database. I'll do a quick search for, say, a function code 121. I'll double click on it, it'll take me to it. Actually, that's not a good example. Let's try a different one. Let's try a function code 41. Let's just go right to it. Here's one here. I select the item, take a look at the item properties. All I have to do is just double click on the block address and it'll take me there. I can also view the connections of the cross-reference bubble itself, and I can hyperlink in this case either by the block address or the cross-reference bubble. Here I'll do the block address, and it tells me it's in a different module, in a different CAD drawing. Let's go to it, and there we are. Now these types of function codes, these function codes 41, 42, 25, 26, 63, 64, those are the commonly used ones for bringing in signals from other modules, either inside the same PCU cabinet or in a different PCU cabinet, or on a different PCU cabinet in a different loop, using function codes 121 and 122. It'd be really nice to be able to sort out some of the cross-referencing, because this is a real big burden on people that do Infinity CAD work. Being able to find the source blocks for these and have a matching OREF connected to these types of blocks. Well, the ArcCAD software has a real nice feature in it. Let's close off all the CAD editors and I'll show you this feature. If I select the project and right-click on the project name, there's a menu item that pops up called Report All Bus Imports. Select this, and you'll see for your project every single module header file for every module is now in the queue. What this does is, when I click the Go button, it'll scan every single CAD drawing in the project and report those types of function codes that are importing signals from different modules. You get to see the block number, the CAD drawing that the block number resides, the type of function code, and its importing address. In these cases, you can see them coming up, plus the descriptor text used in the cross-references is also there. When we're finished, it'll report that all the blocks have been scanned and are now reported. The nice feature about this is that you can double click on any one of these entries. It'll open up the CAD drawing and take you right to it. And if you want to see if there's a source block with a matching OREF on it, you can take a look at the item properties. It'll take you right to it. And there's our matching cross-reference OREF right there. Let's go back to this report bus here. Let's clear this off. If I don't want to do the entire project, I can select either a PCU cabinet or a single module and do the same thing. And you see I'm only reporting, in this case, the contents of a single PCU cabinet. This is quite quick. It'll do this in seconds. And once again, I can just double click on it. It takes me to where the block is. So if users are really concerned about their cross-referencing not matching up this way across the entire bounds of their project or entire plant site, this is a great utility for sorting out those types of errors. And 99% of the time, the cross-referencing errors that occur at a plant site are these types of errors where there's no matching OREF that is broadcasting a signal out across the plant loop or the module bus to a different module. Plus, you may find some have some of these types of blocks. Let's go back in and do this again for the entire project. Some of these may have blanks inserted into the descriptor text for the cross-reference bubble, and some of these are showing up here. Just let it do its work here, and we can take you to some of these as well too. Now these may be just spare blocks that are lying still inside the module that may need to be deleted as well too. So let's click on this one here. We've got, yes, a block that has zero descriptor in it. And if I take a look at the input or the attributes of this block, you'll see that they're all set to the default values. These are just spare blocks, and chances are this is a spare sheet, and that's what this is. So you're not going to be able to find a matching OREF for anything that's in loop 0, PCU 0, or module 0. Okay, so that concludes this demonstration on some of the nice little features found inside the CAD editor.